All right. With this lesson, I need to be very careful about my wording because I'm going to use the word trick. And I don't want you to think that these are trick problems, meaning that they are going to trick you. Rather, I'm going to teach you a trick so that you can trick the problem into being easier. I have no idea if that makes any sense at all. But essentially, what I'm going to teach you is a way to make some problems have easier math. Okay, and again, I'm going to say some because it won't be all of them, unfortunately. But we will be able to use these problems anytime we have a K, so either KA, KB, we've done KC, KP, KSP, so any of our Ks. Anytime you find out that your K is very small, and if you remember from the beginning, we defined very small as being 10 to the negative 10th or smaller. Remember, if it's 10 to the negative 10th or smaller, that is saying a ridiculously small amount of product forms. Essentially, so much so that sometimes we even say those reactions are no reactions, although there might be a tiny bit of a reaction going on. Okay, so if you have a K value that is 10 to the negative 10th or smaller, then you can do what I'm about to teach to you. Okay, so when you get to problems from here on out, the very first thing you should do is look at your K value. And if it's 10 to the negative 10th or smaller, I would write yourself a note, at the top of the problem before you even do anything in the problem. Just write trick for yourself so that you remember that this trick is possible. And again, the reason why we can do it and why we can only do it in this situation is because we are going to get a very, very, very small change in what's actually occurring, since so little reactant is going to turn it into product. So let me show you what this looks like. Their problems are going to look normal. Otherwise, this is a very normal looking problem. But again, you're reading through the problem and you see this incredibly small value. You're going to write yourself a note, hey, don't forget to do the trick. Okay, so let's just go ahead. This will be a good review. Notice all our substances are gases. So we're going to be using everything, looks like so. They tell us initially there was 0.2 molar of SO3, so this will be 0.2. They told us nothing about these ones, so those ones will both be zeros. Then we're going to go through and place our X's. Okay, so we're going to have 2x. What the heck is going? Let's try that again. 2x. I'm going to have 2x, and I'm going to have x. I need to make one side positive and one side negative. Let's make this side positive and this side negative, and then we'll add those together. So 0.2 minus 2x, 2x, and x. So notice nothing's been different yet. Next thing we would do at this point, we know we're trying to find the equilibrium concentration. So we're solving for this final row, and they gave us Kc. So we're going to write our expression. So Kc is going to be the concentration, since it's Kc, of SO2, and it will be squared. And we'll have O2 to the first power. And then on the bottom, SO3 squared, like so. We go to plug in our Kc. The Kc that was given in the problem was 2.4 times 10 to the negative 25th. SO2's concentration is being represented by 2x, and that'll be squared. And then O2's concentration is being represented by x. And then on the bottom, we're going to have 0.2 minus 2x, and that is squared. All right, so at this point, we would distribute, maybe FOIL the bottom here. We would deal with the top of that ratio. Notice what's going to happen up here on the top. If you take a look at this right here, we are going to have 4x squared times x, which is going to give us 4x cubed. Quadratic formula is not quite fun when you're dealing with cubed values, and it's not nearly as straightforward. Now, some of you, for you, that's no big deal, and you say, oh, I could do that problem, that's fine. Well, most of us can't, and most of us don't want to, because it's a lot of math. So I'm going to teach you this trick, and again, you can use this trick anytime your 10 is 10 to the negative 10th or smaller. So 10 to the negative 11th, 10 to the negative 12th, 10 to the negative 13th, etc. All right, so here's what we are going to do. Actually, let me get rid of those greens. Okay, so here's what you do. Anywhere where you are adding or subtracting x from a number, okay, again, anywhere you are adding or subtracting x from a number. So find that in your problem and circle it. So you should have only circled this one, okay, because only that one is being subtracted, added or subtracted from another number. These guys we have to leave alone because they're not being added or subtracted from anything. But anywhere you have an x being added or subtracted from another number, and it can be 2x, it can be 3x, it can be 4x, and it can be plus or it can be minus, it doesn't matter. Anywhere you have any type of x being added or subtracted, you are going to cross it off, and you are going to ignore it. Now, let me tell you why. Because you can't go crazy and just always take away anytime you are adding or subtracting x. Remember, we said we're doing this on really, really small k values. Really small k values are telling you that very little product will form. So x is going to end up being a teeny, teeny, tiny number. And when you end up doing sig figs, and you do 0.2 minus a teeny, teeny, tiny, tiny, teeny, tiny, tiny number, it will still end up rounding back to 0.2. And I'll prove that to you at the end of the problem. So I got rid of this right here. I made kind of a mess, but I got rid of it. And now if you look at what's going to happen with the math, it's going to be a lot easier. We still have some math to do, but it's going to be a lot easier. So on this other side, my 2.4 times 10 to the negative 25th stays the same. And here I have 4x squared, right? 2 squared is 4, and then x squared is x squared, and then times another x. So that's going to be 4x to the third, all over 0.2, like so. Then you are going, ooh, actually this is over 0.2 squared. Almost forgot that. Then you are going to cross multiply. So I'm going to do 0.2 squared times 2.4 times 10 to the negative 25th, and I get 9.6 times 10 to the negative 27th equals 4x cubed. Okay, then I'm going to divide over the 4. That brings me to 2.4 times 10 to the negative 27 equals x cubed. Then I'm going to take the cubed root of both sides, and I get 1.3389 times 10 to the negative 9th. Okay, notice how small x is. That's not our answer, by the way, but notice how small it is. Okay, if I did 0.2 minus 2 times that value, 2 times that value would be 0, 0, 0, 0, 0, and then say around 266 or so. Okay, subtract those two numbers. You get 0.1999999 something, 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 something. What happens when you round it? It rounds back to 0.2. So x was so small that if it was being added or subtracted from a number, it didn't end up changing anything. Now, we couldn't get rid of it where there was just 2x and just x, because those were being added and subtracted from 0. So obviously this amount is more than 0. So we actually did increase. So we can't do it there. But anywhere where x is being added or subtracted to another number, we definitely can do it. So now we'll take our x value. We come back up here. Your answer here is going to just be 0.2 molar, right? Because again, you can plug it in. It's just going to end up rounding off. Then 2 times that really, really small number does give us a change in this column. It's a small change, but it's a change because it was 0 to start with. And then this one will be 1.3 times 10 to the negative 9th molar. Okay, so again, we can do this only if our k value is very, very small, 10 to the negative 10th, and we can only do it where we're adding or subtracting it to another number. So let's go ahead and take a look at the second problem. I'd like to see you pause the video a little bit during this so that you can do some of the work for yourself and then check as we go along. So here's the problem. Go ahead and set up your table. Go ahead and get the whole problem going up until the point where you have plugged in all of your x values in your KSP. So hit pause now and unpause it once you've gotten that far. Okay, so now you have this on your table. Again, you might pause and make sure that this is you have everything plugged in correctly. They gave us an initial concentration only of the H2O. Everything was gases. So you went through, plugged everything in, wrote your Kc expression, wrote your values plugged in. You noticed our KSP or our Kc is very, very small. Okay, our Kc is a very small number. You plugged in your values. Now, anywhere where x is being added or subtracted to a number, we need to get rid of it. So right here, I get to get rid of that part. And again, that helps with the math tremendously. It takes quadratic formula out. So if you take those two and you cross multiply, don't forget to square your 0.1, you're going to get 7.3 times 10 to the negative 20th equals 4x cubed. Divide over the 4, you get 1.825 times 10 to the negative 20th equals x cubed. Take the cubed root, and you get x is 2.6328 times 10 to the negative 7th. Okay, that x value, again, look how tiny it is. That shows us that what we did was okay. We go back up to the problem. What did they want us to do? They want us to figure out what the H2 concentration will be. So they're really only asking us for one of them. So we're going to take that x value and plug it in here. So 2 times x. So this comes out to be 5.3 times 10 to the negative 7th molar. And you could plug it in for the other ones. So this one will be 2.6 times 10 to the negative 7th molar. And then this one will just come out to still be 1.01 because it'll round off. Okay, so problems really are the same problems as before. We're just making life a little easier. Now, if it's not 10 to the negative 10th, you're still going to have to do your quadratic.